In this video, we'll do some more examples of u-substitution. Remember that when we're doing u-substitution, that the inside function, we look for a composite function. We see one here, cosine of the function x to the fourth, and the inside function is what we call u. So let's perform this, all right? So let's let u be x to the fourth, and so then du, the derivative of u with respect to x, is equal to 4x to the third. And then remember, we could treat this as though it was sort of an algebraic fraction. Multiply both sides by dx. And we'd have du is equal to 4x to the third dx. And then dx would be equal to du over 4x to the third. So now I could simply make the substitutions. U is x to the fourth, so I'll replace x to the fourth with u, and dx is du over 4x to the third. So I'll have 4x to the third times the cosine of u. Dx is du over 4x to the third. The 4x to the thirds cancel, and I'm just left with cosine of u. Let's see. So who's the derivative of who has cosine as its derivative? Well, of course, that's sine. So this would be sine of u plus a constant of integration. And then recall what u was. It was x to the fourth. This would be sine of x to the fourth plus a constant of integration. So there's an example of using u-substitution, of taking an antiderivative using u-substitution. Let's take a look at it at another example. All right. In this case, well, it starts to get a little murkier, because notice we have two composite functions. We have tangent to the fourth. So remember, that's like tangent of x to the fourth, all right, where tangent is the inside function, but we also have secant squared, so that's a composite function too. But if you keep in mind, the derivative of the inside function here is this expression. The derivative of tangent is secant squared. That's helpful. If that were the case, the derivative of secant is secant tangent, which we don't have. But notice that this expression here is the derivative of this inside function. So I would tend to let u be this tangent because I have its derivative someplace. So let's let u be the tangent of x. Then du dx is a derivative, secant squared of x. So then multiplying both sides by dx, I get du is equal to secant squared of x dx. This is an actual cancellation. Remember, the definition of du was the derivative of u times dx. So that's that way by definition. And then dx is equal to du divided by secant squared of x. Now let's go in and make our replacements here. All right, remember, u is tangent of x will replace with u, so instead of having tangent to the fourth, we'll have u to the fourth. Secant squared of x is secant squared of x with no replacement, the way that we're doing that. I'm doing this anyway. And then dx is du over secant squared. And the secant squareds cancel, and I'm left with u to the fourth, integrating with respect to u, so that would be u to the fifth over 5 plus c. And now recall, u is tangent, so this would be tangent to the fifth of x over 5 plus c. One of the biggest issues that students run into is remembering what this means when they have that exponent here on the tangent. That means it means tangent of x all raised to the fifth. means tangent of x times tangent of x times tangent of x times tangent of x times tangent of x. It means we raise that to the 5th power. Let me save this so that I don't end up in trouble here. And then let's take a look at another example. All right. Okay. Again, notice we have this composite function, sine to the 7th. That's the quantity sine of x, all raised to the 7th power. The inside function there is sine of x. So let's let u be sine of x. Notice I also have its derivative over here. The derivative of sine is cosine. So then du dx is equal to the derivative of sine of x with respect to x, which is cosine of x, and then du dx times dx is equal to cosine of x dx. So du is equal to cosine of x dx. Dx is equal to du over cosine of x. And so let's make this substitution. In place of sine, we'll put u. So instead of sine raised to the 7th power, I'll have u raised to the 7th power times cosine of x times dx, which is du over cosine of x. I can cancel that du, and I'm left with, excuse me, the integral of u to the 7th with respect to u. Maybe I better write that cleanly. And that would be u to the 8th over 8 plus a constant of integration. And remember, u was sine of x, so this is going to be sine to the 8th of x over 8. But remember what that means. Don't let that fool you. So sine to the 8th of x over 8 plus a constant of integration. Okay, I think I have one more example here. All right, let's take a look at this. Here we have sine of x to the 5th, all right, times x to the 4th, the integral of that. Notice the composite function. Sine is evaluated at the function x to the 5th. So the inside function here is x to the 5th. And then if I take the derivative of, let that be u, u is equal to x to the 5th. Taking the derivative of u, I get 5x to the 4th. And then du dx times dx is du. So 5x to the 4th times dx is du. And dx is equal to du over 5x to the 4th. And so now we have, where we see x to the 5th, we'll replace it with u. Where we see dx, we'll replace it with du over 5x to the 4th. So we'll have x to the 4th times sine of that replacement. X to the 5th is u. And then dx is du over 5x to the 4th. And the x to the 4th cancel. I have a 5 left in the denominator, so this is like multiplying by 1/5. I could take out a fraction of 1/5, and I'm left with the integral of sine of u du. All right, now let's see who has sine as its derivative. Well, cosine has, if I take the derivative of cosine, I get negative sine, but then if I take the derivative of negative cosine, I get sine. So this must be, the antiderivative must be negative 1/5 cosine of u plus a constant. If I take its derivative with respect to u, all right, the derivative of cosine of u with respect to u is negative sine. All right, so negative 1/5 cosine of u is the antiderivative of 1/5 the antiderivative of sine. And now replace the x with, the u with x to the 5th. So it's negative 1/5 cosine of x to the 5th plus a constant of integration. So there is our antiderivative. So here are a few examples of u-substitution. Now, u-substitution, you'll have to just do lots of practice with to get the hang of it, to become proficient.